Om Amriteshwari Namaha, Namashivaya. It's a proud moment of Astro Club. We have Swami Gurunand Jnana Thapaswi with us. So I invite Sriram Murali to conduct today's program.
Greetings everyone. Om Nam Shivaya. My humble prostrations at the lotus feet of our most beloved Amma. We are thrilled to gather here today for another fascinating exploration of the universe. The Amrita Astro Club is an initiative by Amrita Gurukulam dedicated to nurturing the students' passion for astrophysics. Our club aims to ignite a curiosity about the mysteries of the universe, and we achieve this by inviting national and international experts to share their knowledge with our enthusiastic students. Through regular seminars conducted on Google Meet and Zoom platforms, we provide a platform for engaging discussions and enriching learning experiences. Today, we are honored to have with us a distinguished scholar and spiritual leader, Swami Gurunand Jnana Thapaswi, the head of Santhigiri Research Foundation and a renowned research scholar at the University of Kerala. The theme of today's talk is exploring the hidden dimensions of the universe, and we are eager to delve into the depths of cosmic mysteries. In addition to Swamiji, I extend my heartfelt welcome to Jayanti ma'am, Sudhagaran sir, and Shri Julius. As we begin this enlightening session, let's take a moment to center ourselves and embrace the wonders of the cosmos. Let us now offer a collective moment of gratitude and proceed with the prayer. Om Dhyayamo Dhavalavagundhanavatim Tejomayim Naishtikim Snigdhapangavilokinim Bhagavatim Mandasmitashrimukhim Valsalyamritavarshinim Sumadhuram Sankirtanalapinim Shyamangim Madhusikta Suktam Amritanandatmikam Ishwarim. Om Nam Shivaya. A warm welcome to you on behalf of Amrita Astro Club and its members. Swamiji, we feel deeply honored to have you here to lecture on this topic. Your expertise and spiritual insights are renowned, and we are eager to learn from your discourse. Your presence is guiding light on our cosmic voyage. Please take over the session, Swamiji. Nam Shivaya.
Thank you, Sriram. I express my sincere thanks to Jayanti ma'am for inviting me to this particular program. I'm highly indebted to you, and I take it as a great honor. It takes time. I would like to move on directly into the session. Am I audible?
Yes, Swamiji, you are audible.
The picture you are seeing is actually weeks back. And I think those who are familiar with astronomy and astrophysics, they are familiar with the pillars of creation. Have you heard about that, the pillars of creation? It's actually a star-forming region in the Eagle Nebula. So this particular picture, it was taken by James Webb. That is a new observatory like a Hubble Space Telescope that is being sent to the space, and much information is we are getting much information through the pictures that is sent by this new telescope. Even though you people are from the field of astronomy, you're interested in astronomy, today we will be discussing about cosmology. Astronomy, it is actually the branch of science that talks about the motion and relative positions of heavenly bodies. And astronomy mainly focuses on celestial mechanics and optics to learn the positions and composition of celestial objects. And in particular, astrophysics, it is a branch of astronomy that employs the principles of physics, both physics and chemistry, to ascertain the nature of the astronomical objects rather than their positions or motions in the space. So cosmology, today we are discussing about cosmology. It is a study of the origin, evolution, and the ultimate fate of our universe. It studies the universe on a large scale. It studies the universe as a whole. So cosmology differs from astronomy in that the former is concerned with the universe as a whole, while the latter deals with individual celestial objects. So we will be today discussing about the large scale structure of the universe. It is believed that, and science ascertains that our universe began through a Big Bang. So it happened some 13.8 billion years ago. After that, there is a period called inflation period. And after that, the expansion of the universe slowed down a little, and it is still expanding. And this is the graphical representation of that Big Bang theory. So we are not discussing deep into the Big Bang theory, but we are trying to discuss about the forces, the fundamental forces of the universe. There are four forces. That is, the first one is strong nuclear force, then electromagnetic force, then weak nuclear force, and the gravitational force. So of the four forces, gravitational force is the weakest one. So why gravitational force is the weakest one? That's a pertinent question in the field of science or in the field of physics. So if you are taking this strong nuclear force, we will tell about what strong nuclear force, not in detail, but just what it is. If we are ascertaining unity to this strong nuclear force, the electromagnetic force is 100 times weaker than the strong nuclear force. Strong nuclear force operates inside the nucleus. Likewise, the weaker nuclear force is also there, but it is still of lower strength. And the weakest of all the forces is gravitational force. And at the beginning of the birth of the universe, all these forces were united. And that concept is called the theory of everything. After that, after the period of inflation, things changed. During the period of inflation, the gravitational force break apart from the rest of the forces, and the rest of the forces together, they are called, it is called grand unification theory. All the three forces, the strong force, the electromagnetic force, and the weak nuclear force together constitute the grand unified force field. And the gravitational force is away from that. So the strong nuclear force, the electromagnetic force, the weak nuclear force, and gravity. See, you could realize that a small magnet readily overcomes the gravitational pull of the entire mass of the Earth when it lifts a nail off the ground. So even the electromagnetic force is much powerful than the gravity. But we can say that the gravity is highly extensive. The power of gravity is extending to the entire part of the universe, but it is much feeble. Why the gravity is that much feeble? That is the real question we have to address. So regarding the strong nuclear force, it binds the protons inside the atomic nuclei. We know that the protons, they repel each other because they have similar charges. But in a small space of 10 raised to angstrom level dimension, the protons are inside the nucleus. How it is possible to do that? And it is because of the strong nuclear force. So much things are happening inside the nucleus, and there are particles called gluons that glue these protons and neutrons together to form the nuclei. So we need enormous energy to break it off, and when when the breakage of nucleus happens, enormous energy will also be released. Then comes the weak nuclear force. it is responsible for the conversion of protons to neutrons. And it is the base for the beta decay. That is, it is responsible for the radioactivity of elements. I think you are familiar with the radioactivity of elements. It is because of the weak nuclear force. Then comes the electromagnetic force. We are much familiar with the electromagnetic force, and it forms the basis of the atoms and molecules. So when an electron moves from a lower energy level to a higher energy level, it needs energy. So it will be absorbing a photon. When it is moving from a higher energy level to a lower energy level, it will release a photon. So there, the electromagnetic force is operating, and the exchange particle is photon. And the gravity, it is the binding force of this universe. It is adding motion to the universe. Gravity forms stars, planets, and moons, and forces that objects to spin on an axis and move along in its orbital path. The planets appear to be orbiting the center of the sun. The sun and the planets all orbit a shared center of mass. And in our Milky Way galaxy, the entire mass is moving around a central point. It is supposed to be a black hole there. So the entire universe is held together by gravity, but still it is the weakest of all the forces. The first person to discuss about gravity, it is, as we are familiar with, it is Sir Isaac Newton. After that came our Einstein. He explained this gravity as a curvature in the space-time fabric. According to him, the entire space-time fabric, that is the 3 dimensions, and the 4th dimension, that is the time. That is called, they together constitute the space-time fabric. And a massive body will make a curvature. It will curve the space-time fabric towards itself. Whenever we are stretching a cloth and putting a ball at the center, we could see that the cloth will be curving towards the massive particle. Likewise, every massive particle is curving the space-time fabric towards it. So, the particles are constantly interacting through the space-time fabric. Could see an animation of that. When a particle is moving, it is actually curving the space-time fabric towards it. But the centrifugal force is there. It counterbalances the gravitational force, and that makes the orbital motion of the planets and other planetary objects. And it is confirmed that even light could be bent by the gravitational field. It is called gravitational lensing happens, and it is verified by physics, physical experiments also. So, going back to the Big Bang picture, these 4 forces were united at the beginning of the universe. And that period is called Planck era. And that period is called Planck era. So it existed only for about 10 raised to minus 38 seconds. We were able to describe all the happenings after that. But what happened in the Planck era, it is still unknown to us. So we have to go back to the Big Bang to explain how these 4 forces are linked together as to explain the theory of everything. All the matter and the particle can be explained using this theory of everything. For that, we have to move to the beginning of the universe. And it happened, and that area is called Planck era, and all the happenings of that particular time, it is called the Planck length, Planck dimensions. Initially, all the forces were believed to have been equal, very strong. This era is eventually be described as the theory of everything. And gravity became a distinct force, and it broke off. And the rest is called GUT, that is Grand Unification Theory, that combines the strong force, electromagnetic force, and the weak force. And it was that unification was done by Abdus Salam, a Pakistani scientist. So the four physical forces were initially a single force. The symmetry was broken and the universe expanded. As the universe expanded and cooled after the universe was 1 trillionth of a second old. So we have to recreate the entire thing if we have to know what happened at that particular time. So recreating this Big Bang, the scientists prepared a large hadron collider. It's called a Large Hadron Collider, that is LHC. It is devised to recreate the Big Bang process and to find out what happened just after the Big Bang and before the inflation, during the period of inflation. The energy density and temperature that will be made available in the collisions at the LHC are similar to that existed a few moments after the Big Bang. We have to create that much energy, and LHC is looking far back into time, just a few moments after the Big Bang. So we have to recreate the entire thing. See, this is the this LHC Large Hadron Collider. It's a big circular accelerator. There are 4 detectors. That is, these names Atlas, Alice, CMS, all these are detectors. And this particular thing, it is a 27-kilometer circumference large collider. And here, the particles, 2 proton beams are accelerated to very high speed, and they are made to collide each other. And when they collide each other, they will shatter into their finer particles. And these detectors, Atlas, CMS, LHC, and LHCb, that is Large Hadron Collider Beauty, and Alice, all these detectors will be examining what is happening there. So whenever we are throwing a stone on a strong wall, we could see that it will shatter into small pieces, and these pieces will be moving in different directions. See, the particle physics, they could clearly predict the projectile motion of these particles. Here, this is the inside view of the Large Hadron Collider. 2 beams will be moving inside the collider path. One will be moving in the clockwise direction, and the other one will be moving in the anti-clockwise direction. And when they are fast sufficient enough, they will be colliding together. When they collide each other, they will shatter into the finer particles, and the path of the particles and the projectile motion will be detected by the detectors. And that path, see, these are the inside view of the colliders. Some of the colliders. So the particles, the clockwise particle and the anti-clockwise photon, they will be moving in opposite directions and colliding each other. And when they collide each other, they will split off into finer particles. Then we could detect by what these photons are made up of. So you are actually seeing a picture that resulted in the finding of Higgs boson, and it is otherwise called the gold particle. But actually, it has nothing to do with gold, but it is named in that particular way. It was actually named as good damn particle, but because of its strange behavior, but the editor of the book, he just renamed it as not as a good damn particle, but just as gold particle, but nothing to do with gold. So this is the detector image that was recorded on May 2011. And this image and the analysis of this particular image, it led to the discovery of the Higgs boson. So what are bosons? The bosons are particles that are named after our beloved scientist, Satyendranath Bose. He's an Indian. There are 2 types of particles, bosons and fermions. Fermions, they were not able to occupy the same energy state. If there are 2 particles, they cannot occupy the same energy state. Such particles are called fermions. If more particles can take up the same energy level, then they are called bosons. And whenever you are moving on to the +2 classes, you will be dealing with the Pauli's exclusion principle. There you will be learning that all the quantum number, you cannot have particles with all the 4 quantum numbers identical. It's called the Pauli's exclusion principle. But these bosons will not obey the Pauli's exclusion principle. That is, they can have all the quantum numbers equal, or they can have the same energy. Such particles are called bosons. The material particles, they form the fermions. They cannot, as we are familiar, no two massive object can occupy the same space. Likewise, but bosons can. Photons can occupy the same space and the same energy. So that makes bosons and fermions different. See, this is the large picture of the particles. However, the particle world, the world inside the atom is a very exciting one. The protons and neutrons are there. They form the massive particles. Then they are made up of still finer particles called quarks. Protons and neutrons are made up of quarks. There are different types of quarks: up quark, down quark, charm quark, strange quark, top quark, bottom quark, likewise. Then there are leptons, that is the electrons. The particles like electrons. There are electron neutrino is there, muon neutrino is there, muon, then tau or tau neutrino. So 6 leptons and 6 quarks are there. This forms the massive particles. Then there are the force fields. That is Higgs boson, then photon, then weak boson or a W boson and gluons. They form the force field, and the quarks and leptons form the mass. So the entire universe can be classified, segregated to 2, that is the mass and energy. And the mass, it is constituted by the quarks and leptons, and energy or the forces is constituted by the finer particles, the exchange particles of forces, that is the bosons, photons, and the gluons. So this is the big picture of the finer picture inside the atom, or the big picture of the atom. Regarding the Higgs boson, it is responsible for mass in particles after they collide in the Higgs field. So what is Higgs field? Yeah, before moving on to the Higgs field, you could see different cartoon characters. It is not prepared by me. It is prepared by the LHC people. The up quark, down quark, charm quark, strange quark, top quark, and beauty quark. Then leptons, they are electron, then neutrino, then muon, then neutrino muon, then tauon, and neutrino tau. And the exchange particles of force, that is photon, then gluon, then Z0, then the weak bosons, then Higgs boson, and the last one, graviton. See, this graviton, it is the exchange particle of gravity. We will come to that later. See, I discussed all these things just to introduce this graviton to you, but this graviton is not there yet in the picture. We have to find the graviton to explain where the hidden dimensions are. So, in addition to these particles, there are antiparticles. If there are for this electron, you know that there is positron, positively charged electron. Likewise, there is particle and antiparticle is there, matter and antimatter. I'm not moving deep into that. See, this is Peter Higgs, who got awarded the 2013 Nobel Prize for the discovery of this Higgs boson. So, what this Higgs boson is doing? This is the picture in which this discovery of this Higgs boson is announced. It was announced by Lynn Evans. He was the director of CERN at that particular time. So this entire universe is filled with a field that is called Higgs field. See, you have to imagine a party where the guests are evenly spaced around in the room. The room of guests represents the Higgs field. which is everywhere in the universe. Each guest represents a Higgs boson. Suddenly, a celebrity is entering there. Suppose it is Mohanlal or Mammootty entering into the room. Guests notice the celebrity and rush in close to be near the guest. As the celebrity moves through the room, the clump of guests surrounding her gives the group additional momentum. This clump is harder to stop than one guest alone would be. This clump has acquired mass. This is how mass is built up. A different celebrity enters and passes quickly through without attracting any attention from the guest. Then it is weakly interacting with the field and it can freely move on. So the Higgs field is a stuff that gives all other particles a mass. Every particle in our universe swims through this Higgs field. Through this interaction, every particle gets its mass. Different particles interact with the Higgs field with different strengths, and some particles are heavier than others. Some particles have no mass. They don't interact with the Higgs field, so they don't feel the field. The more the particles interact, the more massive they will be. So photons do not interact with the field at all, so they don't have any mass. So the massive particles interact strongly with the Higgs field, while the particles like photons, that have no mass, they will not interact with the Higgs field at all. That makes the difference. These quarks and leptons, they interact strongly with the field, gaining relatively larger mass. So quarks are made up of protons and neutrons. See, protons and neutrons are made up of these quarks. The electrons, that is the leptons, only interact slightly with the Higgs field. So they have lighter mass. And the photons, they are not interacting with the Higgs field, so they don't feel any mass. This is the picture we have about the universe. Now moving on to another dimension. Our universe, the composition of our universe. The 68.3% of our universe is dark energy, and 26.8% is dark matter. We cannot identify or we cannot detect directly this energy and matter. That is why they are called dark energy and dark matter. We cannot see it or it cannot be detected with the existing detectors. The entire universe we are seeing, it is only about 4.9%. So this is the big picture of our cosmos. Majority is dark energy and dark matter. And whatever we are seeing, it is only less than 5% of the. So where the rest of the mass is going, where the rest of the energy is, where it is hidden, we are not aware of that. So the dark energy and this dark matter, they are actually competing each other. This dark matter, it is trying to compress the universe through the gravity, while dark energy is trying to expand by itself. So there is a tug of war between the two. If we are looking into a galaxy, the Milky Way galaxy, for example, it is having a definite mass. We could calculate the mass of this Milky Way. But that much mass is not sufficient enough to hold the entire Milky Way together. Some hidden mass is there, and that mass is called dark matter. But we are not able to detect that through any detectors. And also, when we are observing the universe, we identified that the universe is speeding up in its expansion. And that is because of this dark energy. So dark energy is trying to expand the universe, while the dark matter is trying to hold the matter back to it. So there is a tug of war, but we are not actually able to identify this dark energy or dark matter. This recently in 2020, we launched European Space Agency, ESA, they launched a new detector called Euclid. This is a space telescope, not an optical telescope, but a different thing. that could explore the presence of dark matter and the dark energy. It will be working in association with the James Webb telescope that is already there. They will be combining to working together to explore about the dark energy and dark matter. So that is the experimental part, and we will be discussing about theoretical part a bit. See, this large hadron collider, that is of the circumference of 27 kilometers, it was not able to recreate the Big Bang. That is why we were not able to see into the Planck era, what happened, the Planck dimensions and Planck time. So, scientists are now trying to construct a new collider called the Future Circular Collider. It is about 90 kilometers in circumference, and it will be constructed underground in France and Switzerland. It is not functional yet. It is now under. It is not under construction also, but they are planning to make such a thing. Then only we could recreate the Big Bang days. In the beginning of the LHC program, they thought that they could recreate the Big Bang and identify the particles or the unification of everything that remained at the time of Big Bang. But they were not able to do that, and so they are planning to have and yet another bigger collider. So these are things happening to identify the fine structure of our universe. So we have two dimensions, that is the bigger dimensions and the smaller dimensions. So we'll be exploring deeper and deeper and deeper and to the finer particles, and we have to see the entire vastness of the universe. In both directions, we have to move. So whenever we are moving to the smaller dimensions, 1 by 100 makes centi, 1 by 1000 makes it milli, then micro, nano, pico, femto, that is 10 raised to minus 15. On the larger scale, 1000 times makes it kilo, mega, giga, tera, peta, exta, zeta, iota, 10 raised to 24. So likewise, in both the directions we could move. We are actually in the middle. So we have to explore both the finer dimensions and the finer world and the bigger world to see the extra dimensions. Regarding the dimensions, one point, point is a zero dimensional thing. When the point is moving in time, it forms a line, it has one dimension. So it could move only in length. So there is only one dimension. When then that line is moved, it will become a square. That is, both the length and breadth will be there. That is 2 dimension. And that 2-dimensional thing is moved through time. You could get a cube. It is a 3-dimensional thing that length, width, and breadth are there. So that is a 3-dimensional thing. But yeah, that is our limited. That is the limitation of our sense organs. We can visualize 4-dimensional thing, but we cannot actually see the 4-dimensional thing. Now you are actually seeing a hypercube, that is a 4-dimensional cube. You can visualize in your mind, but you cannot actually see a 4-dimensional object. I will tell you how it happens. Now you are seeing a ball that is bouncing on the floor. See, whenever the ball is bouncing like this in time, actually a 4-dimensional thing is formed, but we cannot see or we cannot identify that 4-dimensional thing. Whenever you are moving in space like this, a 4-dimensional object is actually being created there in time, but we cannot perceive that. We can only see the person. So that is a limitation of our sense organs. We cannot see beyond the 3rd dimension. We can only sense the 4th dimension. We can sense time, but we cannot see the time. So that is our limitation. Our sense organs are limited to 3rd dimension only. Beyond that, we can only imagine. We can only visualize, but we cannot really see the things. So, but we have to move beyond that. See, physics enable us to see the world that is beyond the three dimensions. See, at 10 raised to minus 35 meter, that is the smallest length possible, and that is called Planck length. The largest end, that is the Hubble scale, that is the dimension of the universe. See, the observable universe, it is about 91 billion light years across. 91 billion light years. That means light from that particular point has reached us yet. But beyond that, we were not able to see. That is why it is called observable universe. It is assumed that the real universe may be some 200 to 300 times this particular dimension. We are able to see, are able to detect light from only up to a distance of half of the 91, that is that will be 46.5. That is the distance up to which we can see clearly in the universe. Beyond that, we are not able to see, and that is the end of our, now it is the end of our observable universe. Universe may be extending beyond that, but we are not familiar with all these things. Regarding the scale of the universe, you could just see that the nucleus, it operates at the femto level. That is 10 raised to minus 15 meters. That's the dimension of this nucleus. Beyond that, the quarks 10 raised to minus 18 meters above. So the shortest distance possible, that is Planck length. Is 10 raised to minus 35 meters. Moving to the higher dimensions, the bigger and bigger objects are there. Galaxies, they cluster together to form galaxy clusters or local groups. The observable universe, but the real universe is expanding beyond that. So at the Planck scale, the Planck length is there. That is a 1.616255 into 10 raised to minus 35 meter. See there, then see the fine thing is a string. So that makes the fundamental particle of everything. It is the smallest length possible. Length smaller than this are considered not make any physical sense in our current understanding of physics. So the smallest possible length is Planck length. This is of the dimension 10 raised to minus 35 meters. So the finer thing that is possible is the string. There are two types of string, that is open and closed strings. Let me tell about how the dimensions are being reduced. Whenever an acrobat is moving through a wire, stretched wire, he or she is able to move only in one dimension. That is, there is only the length is there, no breadth. Can move only in the length, along the length. But for an ant sitting on the rope, it can move lengthwise and also breadthwise. It can move around and it can move along. So there are two dimensions for ant, but for the acrobat or for a chameleon sitting on the rope, it is only one dimension. So for bigger organisms or bigger objects, there are lesser dimensions than there are really. So for an ant, there are two dimensions on a rope. Can move around and move along. But for us, rope is an one-dimensional thing. Suppose you are having a fabric with you and it is folded many times. Suppose you are a small virus or bacteria sitting on one of the folds. Some of the the fibers will be intertwining and you are sitting in the space in between the crossing of two fibers, and you could see this fiber as a big thing. If you are imagining yourself as a small virus or bacteria sitting in your own cloth, then you could see that this entire fabric is a three-dimensional thing. Each fiber that is coming outside the fiber thing is actually it's a big three-dimensional thing. But for us, cloth is a two-dimensional thing. The fabric is a two-dimensional thing. But for a virus, it is a three-dimensional thing. Likewise, there is a reduction of dimensions. So whenever we are moving deeper and deeper and deeper, much dimensions are there. Whenever we are moving deeper and deeper and deeper and finer and finer and finer, so hidden dimensions are there. So the dimensions are curled up into each and every point. So every point on this space-time, it is actually a curled up higher dimensional space. I think you could catch the point. Whenever we are moving deeper and deeper and deeper, then finer dimensions are there. And that is called Calabi-Yau space or Calabi-Yau manifold. The geometry of the folded dimensions give rise to different types of observable particles in our universe. You could see that there are space inside the Calabi-Yau space manifold. Connected with each hole in the Calabi-Yau space is a group of low energy string vibrational patterns. The strings are the Planck length objects, that is the strings. They are able to vibrate in the Calabi-Yau space. The nature of the Calabi-Yau space and the nature of the vibration determines type of particles we are seeing. And this particular concept is called string theory. According to string theory, all particles are vibrations on a tiny rubber band. Physics is the harmonies on the string. Chemistry is the melodies we play on the vibrating strings. The universe is a symphony of strings, and the mind of God is cosmic music resonating in 11-dimensional hyperspace. We are actually able to perceive only 3 dimensions and the time dimension, but it is a higher dimensional space, at least 11-dimensional hyperspace. These are the words of Michio Kaku. He is a theoretical physicist. So, what makes the finer structure of our universe? That is the strings that vibrate at each and every point of this universe. There are two types of strings, that is closed strings and open strings. In some strings, they are open-ended. They can interact with each other to build higher higher and massive objects. But the closed loop strings, they are not able to interact with other particles or other strings because they are closed. In string theory, the element, each and every particle is considered to be a different mode of vibration. These quarks or these protons, electrons, neutrons, they are actually made up of combination of strings, and these strings, they vibrate in a particular fashion to make electron. They vibrate in a particular fashion to make proton, and likewise. So the fundamental particle of this universe are just strings that vibrate at the Planck length. All the different fundamental particles are really just different manifestations of one basic object, that's the string. The geometry of the Calabi-Yau manifold determines the way in which the string vibrates. So that makes the difference between the particles. And the strings are vibrating inside this particular space. And these strings can combine together to form bigger objects. And that's how the entire universe is built up into this larger dimensions. The strings, they combine together to form membranes. One-dimensional string, they combine together to form membranes, and that is how that they make three-dimensional membrane, and that is called, and that word is used from membrane, that is brain. So, and this concept is called the brain world concept. So, our universe, the observable universe, is actually a membrane or a three-dimensional brain in an extra-dimensional world of at least 11 dimensions. We are experiencing only the 3 dimensions of space and 1 dimension of time. But the extra dimensions are there. They could be either curled up into small spaces or they could be large as this universe. These strings, they combine together to form membranes. I'm just keeping all these things. This closed, I told you that there are 2 types of strings, there is closed strings and open strings. These open strings, they are attached to this particular membrane. They cannot leave the membrane. They can move through the membrane, but they cannot leave. But there are particles made up of the closed strings. They are called gravitons. See, we just mentioned the name graviton earlier, and these gravitons are made up of closed strings, while all other particles, quarks, leptons, and baryons, all these are made up of open strings. So they remain stuck in this particular universe, while the gravitons, since they are closed, they can move freely. They are not connected to this particular universe alone. Gravitons between Earth and Sun try to escape, but most are blocked by the membrane due to medium range energy. The wavelength of the gravitons emitted by distant galaxies are very small. Most gravitons are free to move into extra dimensions. Therefore, we observe a much weaker gravitational attraction. So why gravitational force is weaker? Because these gravitons are free to escape into other dimensions, while all other particles are stuck up in this particular our visible universe. That makes gravity feeble. And this concept is called a deep brain concept, Dirichlet membrane. So our universe is a Dirichlet membrane on which the open strings are attached while the closed strings are able to escape. So this membrane, see, if it is a one brain might look like a infinitely long telephone wire. It will be having only one dimension. A large two brain might look like a tablecloth, that is a two-dimensional thing, and a three brain could be an incredibly large box. So we are actually in a three-dimensional box made of these membranes. How these gravitons are able to escape? That an analogy can be used. See, whenever balls are moving on a billiard table, they will be colliding each other. They are stuck up on the surface of the billiard table, but sound will be emerging from there. While the particles are moving on the table, sound can emerge from the surface. Likewise, gravitons can emerge from the membrane, while the other entire particles will be stuck up in the membrane. So the only particle that can escape from this universe is gravitons. So that makes gravity feeble. So our universe may exist on a wall. It's a membrane-like thing in the larger extra dimensions. The plane represents our three-dimensional in this. You can see a figure here. This plane represents our three-dimensional universe, in which all particles and forces except gravity are strong. Gravity propagates through all dimensions. The extra dimensions may be as long as 1 millimeter without violating any existing observations. So in just 1 millimeter thickness, you could experience there is actually extra dimensions. The collision between two subatomic particles embedded in the three-dimensional universe produce other particles, including a graviton that escape from our brain into the extra dimensional bulk that lies beyond. This large hadron collider, it was actually planned to find out the gravitons that are moving to the extra dimensions. But since the energy was less, we were not able to detect that yet. And that is why they are planning for the circular collider. So the visible universe could lie on a membrane floating within a higher dimensional space. The extra dimensions would help unify the forces of nature and could contain parallel universes. So what we are actually seeing, it is actually, even though it is a three-dimensional thing for us, it is actually just a membrane. For us, this is a fabric is a two-dimensional thing, but for a virus or a bacteria, it is a three-dimensional thing. So for us, this particular universe is a three-dimensional thing, but at a higher dimension, for a superhuman being, this particular thing may be only a membrane, a two-dimensional thing. That is the reduction of dimension for higher beings. I think you got the point. See, why we are not able to see the other dimensions or the parallel universes? Because the particles, or if you are to be able to see a particular thing, you have to see the photons. But photons are made up of open strings. So one end of the photon will be always attached to the membrane. So it cannot escape or cross-cut through the dimensions. It can only move through the entire length. So it will take billions of light years to reach to our point. But gravitons can simply cross-cut to other dimensions. And these other dimensions are just 1 millimeter away from us. So there is a hidden world just 1 millimeter away from us. But we are not able to see those dimensions because photons from that universe will take billions of years to reach us, because these photons are made up of open strings whose one end is connected to the membrane. But the gravitons, they are made up of closed loop strings, and they can simply cross-cut through the dimensions. And that is why gravity is very feeble, and it is the weakest of all the forces. So this particular image, I took it from Scientific American. It was in the August 2000 publication. All the pictures you are actually seeing, it is from Scientific American. So string theory predicts the universe has 10 or 11 dimensions. Why don't we see these extra dimensions? Because perhaps we are living on a brain floating in a space of 5, 6 or more dimensions, like a soap bubble in the bathroom. The manifold universe theory asserts that the brain we live on could be folded over on itself many times, or it could be stocked in different ways. We will discuss about that later. Light could travel only on the membrane, but gravity could take shortcut by jumping from one fold to the next. Nearby matter on the other folds can be detected gravitationally as unseen dark matter. Since gravitons are being exchanged, and that forms the basis of dark matter. Since it emits light, light takes a long time to reach us traveling around the fold, so we are not able to see it. So dark matter is stuck up in the extra dimensions. So we are not able to see it, but we can feel through the action of gravitons. So this explains here higher dimensions at a higher, the extra dimensions at a higher level. And there are two aspects: the small extra dimensions and the higher extra dimensions. At the small extra dimensions, we have the strings and the Calabi-Yau space. And at the large extra dimensions, we have this parallel universes, or it is called multiverse. There are different types of universe that is just a millimeter away from us. Sometimes something can pass through and shortcut. Some shortcuts are happening, and they are called wormholes. And that forms the basis of time travel. We could shortcut through these higher dimensions. And if it is possible, that help us to travel through the time by shortcutting it. But till this date, we are not able to do that. So string theory envisions a multiverse in which our universe is one slice of bread in a big cosmic loaf. The other slices would be displaced from ours in some extra dimensions of space. So we are in one loaf, and other dimensions, other worlds are there in other loaves. But we are not able to see that. But we could feel that. Okay. See, this extra dimension thing, it was proposed by Dr. Raman Sundaram, and also along with another lady called Randall. This Raman Sundaram, he is from University of Maryland, and fortunately he is from Tamil Nadu. But now he is a citizen of America. So why he is able to predict these things, we will see it later. So there are different types of multiverses. So if there are 4 particles, and after 2 raised to 4 arrangements, the first arrangement must repeat. So if in our universe there are 10 raised to 118 particles altogether, so after 2 raised to 10 raised to 118 arrangements, our universe has to repeat. According to permutations and combinations, our arrangement of this particular universe has to repeat. So there will be a replica of us in some other space. And this is called the level 1 multiverse. It's even though you can see the pictures, but there is mathematical background for all these arguments. And the level 2 multiverse, it says that there are parallel multiverses. Our universe is one among a multiverse. And similar multiverses will be there. So that is called the level 2 multiverse. Then the level 3 multiverse, that is whenever we are throwing a die, see, the one will be in one particular universe. If the die is appearing as one in our world, then all other possibilities exist in other dimensions, other multiverses. So that is another possibility that is called level 3 multiverse. So everything is possible. Every arrangement is possible. If the one is in one particular universe, 2 and 3 will be there in another universe, 6 will be there in another multiverse, 5 will be there in another multiverse, likewise. So in that particular concept, now we are discussing about this multiverse now. In some other multiverse, universe, we might have finished the program and have gone back to our business. But in some other dimensions, other multiverse, the program is yet to begin. So if a person is able to see like a bird's eye view through all these dimensions, you can see the past, present, and future. So the past, present, and future are actually our replicas in the multiverse. If you are able to see, not through our normal eye, if you have the power of vision, you could see through these dimensions and perceive the past, present, and the future. And fortunately, our India was blessed with such seers who could see all these things. Trikalatjnanis, they are called. And the level 4 multiverse, there, fourth possibility is there. There, the physical constants are different. For us, the fine structure constant, the mass of proton, mass of neutron, the mass of electron, the charge to mass ratio of these particles, everything is a particular constant here in our universe. But in some other universe, it will be having different values. That is why we cannot interact. So our modern science says that there are different dimensions. There are much higher dimensions are possible. Alongside our world, there are extra worlds are happening. See, this particular thing, the figure you are seeing here, it is called the Lokas and Talas. 7 logangal. 2 into 7, that is 14 worlds are there in our Indian concept. In Gayatri Mantra, we are reciting above 3 of these. Om, Bhu, Bhuva, Swar. These 3 are mentioned in Gayatri, and they are Bhu, Bhuva, Swar, Maharloka, Jnana Yoga, Tapa Yoga, and Satya Loka. That is the positive higher dimensions or Swarga Lokas. And below, it is called the Patala or Talas. Atala, Vitala, Sutala, Talatala, Mahadala, Rasatala, and Patala. So they are the Lokas and this Talas. So our scriptures are telling about 14 dimensions. And this particular thing, it is not only in the string theory, but also in much other physics experiments are also telling about that. And this is called the Schrödinger cat paradox. The figure you are seeing in the screen is about Schrödinger cat paradox. That is, you may learn about Erwin Schrödinger. He discovered this quantum mechanics in one form, and there is Heisenberg in the other form. This Erwin Schrödinger, he proposed a particular thought experiment in which there is a box, and inside the box there is a cat, and there is a radioactive material is placed inside that. There is a radioactive detector also. Then there is a hydrogen cyanide glass bottle is also placed there. If the radioactive decay happens, then the detector will be detecting it. And if detection happens, then a hammer will be falling and it will break the hydrogen cyanide glass bottle. Then the cat will smell the hydrogen cyanide and it will be dead. We cannot predict whether the radioactive material will emit radiation or not. The entire thing is closed inside a box and we are staying outside. So from the outside view, we cannot predict whether the cat is alive or not. This is an experiment that connects the quantum world with the classic world, the bigger world. The quantum world, that is the fine world of atoms and nuclei. In the larger universe, the three-dimensional world we are living in. This experiment connects both. Cat is a three-dimensional thing, while the radioactive substance, it is a quantum thing. So it connects, this experiment connects both quantum and the classical world. The Schrodinger cat paradox says that we cannot predict whether the cat is alive or not. If whenever we are opening the box, if cat is alive, then the many world theory tells that cat will be dead in some other universe. And if the cat is dead, and that cat will be alive in some other universe. We are alive here and hearing and sitting together here, but we are dead somewhere else in other universes. So this multiverse concept is there in many parts of the explanation of physics. So we have to go back to the Big Bang to really know what happened during that particular time. And also beyond the Big Bang. So what happened beyond the Big Bang, we are not able to predict. Science predicts about the Big Bang and what happened, but what was there beyond the Big Bang? That's also a question. So what happened before the Big Bang? See, string theory could explain that also. Our three-dimensional world is actually a membrane. These brains could come closer and collide each other. When they collide each other, there will be much energy outbursts, and the entire material world will go back to the energy world. Only energy will be there. Then what happens? They will move apart, they will cool off, and again galaxies will be formed. So brains, there are parallel brains. We are in one brain, and a similar brain is just 1 millimeter thickness away from us. At some point of time, these brains could collide each other. They will come together and collide each other. Then what happens? They are now moving apart. At some point of time, they will come back and collide each other. And after the collision, what happens? The entire mass will be converted to energy, and the entire process begins. Cooling off, formation of galaxies, formation of stars, formation of these particles, and the entire thing repeats and repeats and repeats. And this is called cyclic universe theory. The brains, they can come together. They will collide. That collision forms the Big Bang. So it is a cyclic process. So the membranes, they come together, collide each other, they move apart, cool off, form the galaxies, form the particles, and at a point of time, because of that gravitational pull back, they will be coming closer and closer and closer. Then again colliding, again moving apart, again colliding, again moving apart. So this is called a cyclic universe theory. So there is actually no beginning of the universe. There is no actually ending of the universe. It is an ongoing process. See, in our Indian concept, the timeline of our Indian concept is a very interesting thing. Now we are in Kali Yuga. Its length is supposed to be 432,000 years. And double is Dwapara Yuga. And double is 3 times is the Treta Yuga and 4 times is the Satya Yuga. And the entire 4, that is called the Chatur Yuga. And 72 Chatur Yugas form one Manvantara. Manvantara, that is the time period of one Manu. The first Manu is supposed to be Swayambhuva Manu. And 1000 Chatur Yugas form one Kalpa. And now we are actually in Shweta Varaha Kalpa. The Kalpa in which we live, it is called Shweta Varaha Kalpa. So after Kalpa, Kalpanda Kalam, after the Kalpa, the brains will collide, entire mass will move back to this energy, cool off, then come back again, and the cyclic process repeats and repeats and repeats. So what finally I have to tell is that whatever we are coming through the entire cosmology, and what we have been discussing is quantum cosmology. And whatever quantum cosmology is revealing as scientific explanations of the existence of this universe, we've had all these things in our scriptures, in our Bharatiya concept. So we have to revere, how to go deep into the concepts revealed to us. So all these things, these hidden dimensions and the extra dimensions, they reveal how much knowledgeable our seers were. The Guru Parampara of our world, of our Bharata. See, no other people were able to see all these things in their scriptures. See, that is why Raman Sundaram was able to propose the many world theory and all the mathematical calculations that made it possible and made it acceptable to the scientific world. Many of the pictures you saw in this presentation, it was taken from Scientific America. So why I made this presentation is because to inspire you to think in this direction, go deeper into the knowledge system of our Bharata and see the hidden gems in that. Okay, you brilliant people could see much more deeper into the things and come out with much newer diamonds for that. See, I came to know about all these things in my later life, but you children, whenever you are moving through the through your education, please keep all these things in your mind and take your studies so seriously and try to see the hidden dimensions in everything you see. See, much things are hidden beyond our eyes. Our eyes are a limitation to us. We can perceive only the 3 dimensions. We cannot see beyond that, but much things are there. Okay, thank you.
Namaskar, Swamiji. On behalf of the entire Astro Club, I extend our sincere gratitude to you for gracing us with your profound wisdom. Your lecture on this topic has been really inspiring and informative. Your unique perspective and depth of this knowledge have left an indelible mark on all of us. We are truly honored to have had the opportunity to learn from you and gain the valuable insights into the mysteries of the cosmos. Your presence has enriched our cosmic journey, and we are immensely grateful for your time and generosity. Thank you once again for being a guiding light on our path to understanding the vastness of the universe. Thank you, Swamiji. Now we move on to the next agenda, which is the QA session. If anyone has any questions to ask to Swamiji, they may either post in the chat session, or they may raise the hand so that we can coordinate the QA session accordingly.
Thank you, Swamiji. Let me just send Anas. In spite of his busy schedule, we are really grateful to you that you have come and address the children. It was really a wonderful session, Swamiji. So much information at a glance. Thank you so much.
So we will conclude the session with the Shanti Mantra. Om Asato Ma Sadgamaya Tamaso Ma Jyotirgamaya Mrityorma Amritam Gamaya. Om Shanti Shanti Shanti. Om Lokah Samastah Sukhino Bhavantu. Lokah Samastah Sukhino Bhavantu. Lokah Samastah Sukhino Bhavantu. Om Shanti Shanti Shanti. Om Shri Gurubhyo Namah. Harihi Om.